So what we're going to do is start with looking at that 19 and 20 that people seem to struggle with, and then we'll go over the review, because tomorrow is the quiz. And I don't think we're expecting all that snow tonight. Let's check real quick. I hadn't heard anything about that. I can check very quickly. I thought we were expecting maybe some rain tomorrow. Let's see. 30% chance of snow, it says. No, tonight, partly cloudy, mostly cloudy, fog after midnight. Nothing tonight. Tomorrow, drizzle in the morning, then light rain, possibly mixed with snow, highs in the mid-30s. Snow possibly mixed with rain up to an inch. That's not much. Friday, nothing. Light snow. Saturday, snow likely. Sunday, snow likely. So maybe Saturday, Sunday they were talking about. So, sorry, ladies and gentlemen, there probably will not be a snow day before Christmas this year, which is the first year in many years that we haven't had a snow day, at least sometime before Christmas. So, but it looks like some snow coming before Christmas, which will be nice. So everything will be nice and white, and Santa can land on your roof with his reindeer, right? Deliver your presents. Because when there's no snow, you always wonder, is the sleigh going to damage the shingles? But now it's snow, and then you're good. You can make a snowman out front to greet Santa, and maybe you'll find a magic hat and put a hat on it, and it'll turn alive and march through town. I haven't seen Frosty yet this year. I got to watch that one. I love Frosty. Okay, back to pre-calculus. But not that I'm distractible today. Oh, squirrel. Okay, good. Pardon? Oh. Do you need a drink of water, Casson? Okay. Someone was doing that in one of my other classes the other day, and it's like coughing and hacking. I said, do you need a drink of water? And the problem was they had just taken a drink of water and swallowed the wrong way. I said, no, that's really the problem right now. Oh, sorry. So, anyway, good story. Tell it again. I know. Sorry, I'm looking for the page. That's what caused me a little. 1920, secant of the cosecant inverse of 4. All right. Okay. Well, first thing I would do with this is, since I don't work well with cosecant inverse, I'm going to change that right away to sine inverse. So the secant of the sine inverse of 1/4. Because it just, in my mind, that works a lot better for me. I say, okay, sine inverse of 1/4. 1/4 is not an identity angle solution, is it? Nope. Sine 1/4 is not identity. So I'm going to have to draw a picture. Sine is positive, so we are in quadrant 1. Sine is opposite over hypotenuse, so 1/4. So this is going to be the square root of 15 on this side. Because square root of 16 minus 1 is 15 square root. So I've got my Pythagorean theorem there to find my third side. And then to find the secant of that angle. Secant is reciprocal cosine. Cosine is adjacent over hypotenuse, so it'll be hypotenuse over adjacent. So this is going to be 4 over root 15, which I then rationalize. And I get 4 root 15 over 15. Okay? So there we are. Number 20 was similar. Sine of the tangent inverse of 12/5. Not so bad, actually, but again, 12/5 is not identity for sine. So we go back to drawing our picture. Since it's positive, we know we're in quadrant 1. That makes life easier. Again, the tangent is 12/5. That's opposite over adjacent. So that makes this side 13. Nice Pythagorean triple. And I just take the sine of that angle, opposite over hypotenuse, 12/13. That's all there is to it. Yeah.
Can you give me 17?
I can. Oh, no, not that. Yes, I can. Sine of the cotangent inverse of square root of 2. Again, I prefer to deal with the tangent inverse, so I'm going to take the sine of the tangent inverse of 1 over root 2. It should be root 2 over 2. Now, the root 2 over 2 makes it sound like it's identity, but that's not an identity for tangent. That's an identity for sine and cosine. So, again, draw my picture. Tangent is 1 over root 2. Okay, opposite over adjacent, which 1 squared is 1, root 2 squared is 2, so this would be the square root of 3 for that side. My Pythagorean triangle. And the sine of that angle would be root 2 over root 3. I'm sorry, the sine of that angle, not the cosine. Sine would be 1 over root 3, which I then rationalize. So that gives me root 3 over 3. And again, root 3 over 3 is an identity solution for tangent, not normally for sine. So it is a slightly different triangle. But again, it just takes to drawing the triangle. And the thing is, if you don't remember your identity angles, if you're having struggles even with the identity values, you can still use this method. The drawing the triangle. Just got to make sure you get in the right quadrant if you're negative. If it's going to be negative, you got to make sure you're in the right quadrant. And usually if they're reciprocal, it doesn't matter unless it's tangent. Tangent, then you do have to be very careful because tangent and cotangent are negative in different quadrants. Cosecant and sine are tangent in the same quadrant. Secant and cosine are negative in the same quadrant. Okay? Anything else? Yes?
For numbers 15 and 16, why do they end up being positive when they start out negative?
Okay, because 16, let's take a look. Sine of arc cotangent of negative 1. Okay. All right. That is an identity, so we can work at it from that perspective, but let's do it from the graphic perspective, because let's say we just don't recognize this as an identity. Cotangent is adjacent over opposite, right? And cotangent is negative in which quadrant? Our cotangent is negative in which quadrant? 4 or 2? 2. Okay, and to remember that, we have to go back and think about what does our graph of y equals cotangent x look like. Our first period of that graph looks like this, right? With this being pi over 2 and this being pi. So that tells me that we want to work with quadrant 1 and quadrant 2, not quadrant 4 over here. So that's one full period of the function. So from a unit circle standpoint, we're in quadrant 2. Cotangent is negative 1, so that's adjacent over opposite. Obviously, this is a negative 1, this is the 1, and this is going to be root 2. And I want the sine of this angle. Well, sine is opposite over hypotenuse. Sine is positive, hypotenuse is positive. So 1 over root 2, which we rationalize, gives me positive root 2 over 2. So even though the tangent is negative in that quadrant, or the cotangent is negative in that quadrant, the sine is positive.
If you were to do it with the identities, like change arc tangent negative 1.
That would be, so then this would be 135. So sine of 135 is root 2 over 2, positive. Because you have to be in quadrant 2. Anything else? All right, then let's look at our review problems. Because we do have a quiz tomorrow. All right. And I guess Friday will just be makeup day, whatever. Maybe I'll have to bring in a copy of Frosty the Snowman or something like that. That'd be okay, right? We'll see. I don't know if I've got anything that'll play on this computer. All right, write the inverse function. Y equals 3x minus 7. To write an inverse function, what's our process? We switch x and y. So x equals 3y minus 7. Then we solve for y. So add 7. So x plus 7 equals 3y. Divide by 3. Y equals x plus 7 over 3. That'd be the inverse function. Now, the fact there's an x squared here makes it a little more interesting, but still the same process. X equals y squared plus 1. So we subtract 1 from each side. So y squared equals x minus 1. So y equals plus or minus the square root of x minus 1. Now, since we're taking that square root, we should have the plus minus there. But the process is pretty similar. You just take a square root at the end. Okay, expressed in radians, domain is all real numbers. Now, I'm being very specific here. I don't want just the primary solutions. I want all solutions. So we aren't doing the limited function here with a limited range. I want all solutions, primary, secondary, plus 360n, actually expressed in radians, so it'll be plus 2 pi n on everything. So arc sine of 1/2, 0.5. What angle, what's my primary solution there? Now, yeah, you could use your calculator to find that primary solution in degrees and switch it to radians, that's okay. But what angle in radians gives me a sine of 0.5? Pi over 6. So I have pi over 6 plus 2 pi n. What would my secondary solution? Because there's another one. Think of the sine graph. Okay, pi over 6, better be pi over 6 in this way. What would that be? Since this is pi right in the middle, 5 pi over 6, yeah. So we get both solutions, actually all solutions. Cosine inverse of root 3 over 2.
Are they all going to have
Unless it's a 1 or a negative 1, yes. Cosine inverse of root 3 over 2. Where is cosine equal root 3 over 2 primary solution in radians? Pi over 6 again. Plus 2 pi n. And again, that's because it's all real numbers. But where's the second one going to be for that? Well, we got to think of our function. And actually, there are a couple ways we could do this, okay? Pi over 6 in, pi over 6 in. Symmetry. So that would be how many pi over 6? 2 pi is 12 pi over 6. Take away 1 would be 11 pi over 6 plus 2 pi n. I would also accept negative pi over 6 plus 2 pi n.
Does that work with the other one too? Could you do...
No, because the symmetry is different. This is an even function. It has symmetry in the y-axis. This is an odd function with symmetry in the origin. But again, very helpful to know your basic graphs. And come final exam time, and about 8 days after we come back from break, actually 9 days after we come back from break is the exam in here. This is the first exam of your entire exam session. Aren't you excited? I know I am. Get it out of the way. You'll be expected to know those graphs. Just be prepared for that. Being able to graph the basic functions. That's going to be there. Okay, all that stuff. It's all good stuff. Primary solutions only. Okay, notice we've changed the instructions. Now it's not saying give all real numbers. All we're looking for is the primary solution. And, you know, you get to use your calculators in this test, so that's probably going to help. Excuse me. So, the arctangent of -1, and in radians, of course. Negative what? No, negative √2/2. What angle gives me a tangent of -1? What does your calculator tell you? It's not going to give it to you in radians. It's going to give you some decimal for radians, but get it in degrees and then convert it in your head to radians. Pi/4, negative pi/4. There we go. Because negative 45 when you plug that in your calculator, right? Although you really should know that off the top of your head. You're going to have your calculator make use of it, I guess. Cosine inverse of negative √2/2. Well, pi/4 would be positive √2/2. 3 pi/4. And again, just, you know, cosine function, pi/2 is going to be negative. We're going to be here in the pi/2 to pi range. √2/2 is the halfway. That's 3/4. Half pi, 1 pi, 3/4 pi, √2/2. Evaluate to the nearest degree, obviously requiring a calculator. And in degrees. Oh, joy, happiness, rapture. So this first one, we just plug in our calculator. Arctangent of 2.415. I don't know what that is. So tan inverse 2.415. 67.5 degrees. So we'd round that up to 68 degrees. Sine inverse of negative 0.8927. Again, just plug that directly in. Whoops, negative 63 degrees. Arc cosecant of 5.126. Ooh, I don't have a button for that. So instead we're going to have to convert that to the reciprocal function, which, what's the reciprocal cosecant? Sine. Right? And I get 11.2 degrees, so 11 degrees is the nearest degree. Cotangent inverse, again, same deal. Although I have to be a little bit careful on this one. Because when I switch to tangent inverse, it's going to put it in the wrong quadrant, doesn't it? Because it's negative. Cotangent inverse has to be between 0 and 180. Tangent inverse is between negative 90 and 90. So when I switch this to tangent inverse, because I have to for my calculator, okay, and tangent cotangent is the only one that gives me this problem, and only if it's negative. It gives me negative 65 degrees. However, I can't have that as my solution because cotangent inverse is not defined at negative 65 degrees. That's not an acceptable solution for cotangent inverse. So how am I going to get to the cotangent range? Just add, not 360, add 180. Yeah, just add 180. So when I add 180 to that, that is 115. So they have to be in quadrant 2. And again, the only function you got to worry about that with is tangent cotangent, and only if it's negative. Sine and cosecant, no worries. Cosine and secant, no problems. Just tan cotangent, and then only when it's negative. If it's positive, you're golden. So that's the only one that's tricky, like that. Approximate to 4 decimal places the cosine of the arcsine of 0.2175. Again, this is just calculator. And you can just plug that directly in. Cosine of the sine inverse of 0.2175. Double parentheses. I get 0.9761. Same with tangent of the cosine inverse. Tangent. Cosine inverse. 0.9595. It's 0.2936. So again, a lot of these problems very calculator friendly. Very straightforward. Just make sure you punch the right buttons. Okay, when you're done, make sure you put the right things in here. It's way easy to just hit the wrong button and wind up with the wrong answer. So double check. Tangent of cosine inverse 0.9595. Yep, that's what I put in. Okay? So make sure you hit the right buttons. Find the exact value. So here, we would not use our calculators. Here's where we do our XYRs and that sort of thing. Or if it's identity, we use identities. The cosine of the sine inverse of 4/5. Again, sine inverse positive, quadrant 1. Sine is 4/5. I mean, that's going to be a 3 to make my right triangle, so the cosine is going to be 3/5. Pretty straightforward. Secant of the arctangent of negative 8/15. Ooh, we are negative. Arctangent is negative in which quadrants? 1 and 2 or 1 and 4? So tangent is negative in 2 or 4? Tangent is 4. Yep. Cotangent is 2. Tangent is 4. Tangent is opposite over adjacent. Pythagorean theorem gives me the third side of 17. So I take the secant, which is, secant is the reciprocal of cosine. Cosine is opposite, or adjacent over hypotenuse is hypotenuse over adjacent, 17/15. Because hypotenuse is positive and adjacent is positive. And draw the picture. Don't be afraid to draw the picture. Don't try to do it all in your head. Draw a picture. That way, if you do make a little mistake, at least I can give you credit for having the right picture. If you draw it in the right quadrant, give you something. This is kind of a fun one. Cosine of the tangent inverse root 3 over 3 plus sine inverse 1/2. We haven't done one like this. But it's not hard to figure out, because those are both identity angles. What's the tangent inverse of root 3 over 3? What angle gives me that? Now, it's not saying express in radians or degrees, so we can go with degrees. What is it? 30, yes. So that's cosine of 30 plus, what's the sine inverse of 1/2? 30. So that means cosine of 60. That looked really complicated, didn't it? It's really not. Cosine of 60 is 1/2. Very straightforward. Very straightforward. So a little different, but nothing that should be too complicated. And that pretty much covers what's going to be on the quiz tomorrow. Not so bad. Now, what can we look forward to when we come back from break? Because we still have a half a chapter to cover. What are we going to do? Well, what we're going to do is we're going to start looking at and using the trig functions to solve equations. So if I get an equation like 3 cos theta minus 7 equals, let's say, -5. And so we have to solve that equation. Add 7 to both sides. 3 cos theta equals 2. So cos theta is 2/3. Aha! And now we can actually solve an equation. So we're going to take this and we're going to, what would be the right word? Algebraize? I just made that up, I think. I've just made up a new word. Life is good. But we take and we put things in algebra form, and then we use our inverse functions to help solve equations. Yay! That's what we get to do when we come back from break. And there'll be factoring and quadratics and linear equations and all this fun equation solving stuff, because it's our last new thing before we switch totally back over into algebra again for second semester. So that's what's kind of coming up after break. Yeah, I knew you'd be excited just so you have something to look forward to for coming back, right? All right, so quiz tomorrow. And that's pretty much it for the year.